on the matter of volume. As a reminder, if you're going to be calculating volume, and yes, we will be doing this, there's certain things to know, like for example, the volume of a cube is side times side times side. So then if given the dimensions of a cube, people should be able to calculate what the volume is. And this is a good time to note that aside from, okay, side times side times side, notice the units here. And I guess maybe you could have boxed this answer where it's centimeters cubed. Why? Well, just like 4 times 4 times 4 is 4 cubed, centimeters times centimeters times centimeters is centimeters cubed. Remember, we're treating units like numbers. They can cancel or they can have powers, as in like 3 centimeters to the 3rd power. So, what if you want to convert that to something else? Because this is a question to ask. What if we want, instead of cubic centimeters, what if we want something else like, I forget what example we used here. Okay, there you go, meters. Oh, there you go, sorry, I overlooked that. What if we want meters instead of centimeters? Well, it is possible to directly convert cubic centimeters to cubic meters, but that involves a couple extra steps. We can actually do it a little more simply. I mean, look, why go through any extra steps when you can simply convert 4 centimeters to what it is in meters, using all the steps we've talked about before. And then once you have it in meters, you just take the number of meters times the number of meters times the number of meters and get a cubic meters. Remembering, of course, to round correctly and box your answers, because 2 sig figs, 2 and 2 should produce 2. And boxing with units and scientific notation and correct round. Now, having mentioned that, let's talk density. When it comes to calculations involving density, yes, we want you guys to understand the mass and a quantity of a given quantity of a substance's density. Okay, what does that mean? It means how much mass is packed into a particular volume. So you guys should know that foam, we often would say it's very light. What we mean to say is that a certain amount of foam is going to have very little mass per its volume, compared to the same size of iron would be very heavy. And the idea is, so density just tells you how much mass is packed into a given volume. So what we want people to be able to do is not only calculate density, but do conversions involving density as well. So what does that look like? Let's start simple. Calculating density. If this is the units for solids or liquids, actually the unit tells you exactly what to do. Grams per centimeter. By the way, what does this mean? If this is the number of grams multiplied or divided by centimeters? If you answer that correctly, you say grams divided by centimeters. That's it. That's your process. As in, your mass divided by your volume. I realize I said centimeters instead of centimeters cubed. Hopefully the viewer gets the idea. Or grams divided by milliliters. It's some sort of mass divided by some sort of volume. So no matter what we give you, it's going to turn into basically that. So your mass divided by volume will give you something. Yes, keep an eye on your sig figs, round properly. Oops, there we go. And that's what you're going to be working with. Now, having mentioned that, what could we do? We could give you something in a different unit. What if we gave you pounds instead of grams? Well, you'd have to convert to grams if you wanted to have these units. Like, that's the sort of thing that's the sort of place we're going to with this.
So let's look at these example calculations. So when we look at these, they'll ask you things to do with density, like what is the density or the mass or the volume or things like that. And we are aware that any of these questions, when you calculate with density, can be answered using the formula density equals mass over volume. And then you can rearrange the formula, plug in numbers, and get answers. And although that is in theory possible, for the purposes of this course, this is forbidden and this formula should never be used in your work. The reason why is because G equals M over V, in many cases, becomes a magic box that students plug numbers into and get an answer, and they have no idea why the answer is right. They have no idea why they got the number they got. It just becomes the magic box that spits out the right answer, and that's not what we're looking for. We want students to understand why the answer is right and why the numbers are producing the answer that it produces. Therefore, for your work, rather than this, you need to show us how you made the units give the desired units of your answer. Now, don't expect this to be given to you on the test, of course, but for the sake of practice, this is given so that you can calculate it and then see if you're right. So let's talk about how you go through this if this were a test question. If you are seeing this on a test, the first thing to know is that it's saying, what is the density? And you know that density is either grams per cubic centimeter, or if it's a liquid, grams per milliliter, because grams per cubic centimeter is for solids. So you should know density refers to one of these two. Now, in this case, since this would not be visible on a test, you would have grams and you have cubic centimeters. And so in the absence of instructions otherwise, you assume your answer would involve grams per cubic centimeter. Now, look, if you're going to get units of grams per cubic centimeter, it should make sense that you are getting this by, look, it says divide grams by cubic centimeters. The unit tells you what to do. If the units of density are grams per cubic centimeter, it tells you to take grams divided by cubic centimeters. So there's your grams, and there's your cubic centimeters. So if you do this, you will get density. So what you do is you set up your units first. You have centimeters, you have grams. So if we take grams divided by centimeters, we get the right units, and that's what we're looking for. Remember, don't use this, don't write this anywhere on your paper. All right, so what you do then is you plug in the numbers after you have verified that it will give the units that you want. So this is where you start. Units doing something gives the units that you want. After that, you can plug in the numbers. So gram is associated with this number, so you put this number next to gram, 549.7. And then centimeters cubed is associated with this number, so 475.98. Once you've done that, you'll do your calculation and you'll get something. 549.7 divided by 475.98. Oops, that's in scientific notation mode. Let's put that in regular mode. There we go. So you'll get 1.154888, all that stuff. Make sure you don't fall into the temptation of just writing whatever number is there. Make sure you round correctly for significant figures, noting that there are 4 sig figs here, 4 sig figs here. So you got to round to 1, 2, 3, 4 sig figs. So this 4 is next to an 8, it becomes a 5, and that's why you get this for your answer. 1.155 grams per cubic centimeter. Box your answer, of course. All right, so that's how you go about this. Set up the units, plug in numbers, and then solve. So we can do that here too. It says, what is the mass of an object with volume of 9.35 centimeters and a density of 2.847 grams per cubic centimeter? So again, you wouldn't see this on the test, but we give it to you for convenience's sake. Mass. You should know mass is, in general, unless otherwise specified, going to be grams. You should know that. Mass is grams. Grams is mass. If it doesn't tell you what is the mass in grams, you'll just look through, you'll notice, oh, look, there's a grams right here. So assume you know grams is a mass unit. So just assume your answer will be using the units given. If it asks for mass unit and you see grams, use grams. If it asks for mass unit, gives no instructions, and gives kilograms, then fine, give kilograms, whatever. So that said, you need to figure out how to make these units give grams. So you got centimeters cubed, and, oops, let's make that clearer, and you got grams per cubic centimeter. So you got to figure out a way to make these give grams for an answer. Now, luckily, this is actually pretty easy, because look, if you take centimeters cubed and times it by grams per cubic centimeter cancels cubic centimeter, and you have grams for an answer. Oh, that is so perfect, we can totally use that. So we're going to do that. Cubic centimeters times grams per cubic centimeter equals grams. So how does that look? We have cubic centimeters is attached to this number 9.35, so put that right here. And then grams per cubic centimeter is attached to this right here. Notice the 2.847 is next to grams. Make sure it goes next to grams. So there you go, I put 2.847 grams. What goes on the bottom? When you see centimeters on the bottom by itself, that's an implied number 1. So basically it's just an automatic number 1 goes where there's no specified number. So what it's telling us is we take this times this divided by this. And then when you do it on the calculator, you get 9.35 times 2.8, Oh, can't even type right. 847 equals that number. Now, what you'll notice, again, you get a whole bunch of numbers on here. Round correctly. 3 sig figs, 4 sig figs. Make sure you got 3 sig figs for your answer. That's where this came from, because the 6 is next to a 1. So that's why it just 26.6. Okay, the process you're seeing here is called unit analysis, using the units to figure out how things cancel so that you get what you want. Again, I know you can do this with D equals M over V, but don't you dare even try. We want to see you understand how to cancel units and how these units interact with each other to give the correct units and the correct quantity, and indirectly the correct number. So make sure you show us how you figured out the way units cancel so that we can see your process. All right. That said, let's move on. The volume of an object. Okay, it doesn't specify what volume unit it wants. So we're just going to go with, oh, there's a volume unit. So we're just going to go with cubic centimeters because it's there and it's a volume unit. And there's no other volume units mentioned. So how do we need to figure out how we're going to get cubic centimeters. And somehow we need to get grams per cubic centimeter and gram to give this, because we have grams unit and we have grams per cubic centimeter. Now, problem is, if we do this, we don't get cubic centimeter, we get grams squared per cubic centimeter, because grams times grams is grams squared, and then cubic centimeters on the bottom and nothing cancels it. So this is not a volume. This doesn't work. So wait, how do we deal with that then? And the answer is, well, what can you? Yeah, well, there's a few things, but you can try dividing stuff, which is true, and that actually will be kind of what's going to get us this. So, what I mean by dividing stuff? Here's what I mean. What if instead of grams times this, we did grams divided by grams per cubic centimeter? Turns out, if you divide by something, it's the same as just, this is the same thing as grams times centimeter cubed per gram. As in, if you flip the fraction upside down, if you divide by a fraction, it's the same as timesing by the fraction flipped upside down. You can do that. You can flip the fraction upside down. That's a wonderful property of math. And look if we could do that. If we could put the centimeters cubed on bottom and grams on, centimeters cubed on top, grams on bottom, if we can flip the fraction, now gram can cancel gram and give cubic centimeters, which is exactly what we want. All right, so yes, you can flip a unit upside down and times it by the upside down unit. There is a catch that goes with that, though. So again, gram cancels gram to give cubic centimeters because we flipped this so that now cubic centimeters is on top, grams on bottom, and then gram cancels grams. Notice what's going to happen when we put the numbers in. So that's what we do with the units. Now let's do the numbers. Gram has the number 938 associated with it. So 938 grams times cubic centimeters per gram equals cubic centimeters. You see, this is the gram and cubic centimeters. See, this is it up here. Notice how 3.75 is associated with it. Earlier I pointed out with the other example, here it is, that this 2.847 is associated with the grams, not the cubic centimeters. So it goes with the grams because it's next to the grams. The same is true here. 3.75 grams for every 1 cubic centimeter is what this is saying. 1 cubic centimeter has a mass of 3.75 grams. So what it's saying is that number's got to stick next to the grams. So the 3.75 goes down here next to the grams, and you just put an implied 1 right there. Because, and I didn't mention this before, but it is true, a density tells you what the mass of 1 cubic centimeter is. So 1 cubic centimeter is a mass of 3.75 grams. So 1 cubic centimeter is a mass of 3.75 grams. There you have it. So if you're going to flip the units, you got to flip the number 2 as another way of phrasing this message. So what it's now is telling us to do is the math is saying, take this number, multiply it by 1, divide it by 3.75. So let's do that. 938 divided by 3.75, because after all, timesing by 1 doesn't do anything, gives 250 point blah, 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 all that. Now notice 938 is 3 sig figs, and so is 3.75. That's the reason why you got to round to 3 sig figs here. So there's your first significant figure, the 2 right there. That's your second sig fig, the number 5. Your third sig fig is this number 0. 0 is next to a 1, so it doesn't round up. That's why it just stays a 0. Now, if you do this, that's not 3 sig figs, that's just 2. Adding the decimal makes it 3 significant figures, and then you can box your answer. All right, so that's why we do it that way. All right, let's talk about how to find the volume of a cube with this density and this mass. Now, in order to find the volume, you have to understand which of these is a volume unit. It's this one, the cubic centimeters. And that means these two mass units must cancel. So milligrams and grams, however, do not cancel because they are not the same. In order to rectify that, one can either convert this to milligrams or convert this to grams. Now, either would work fine, but I'll convert this one to grams. That way grams cancel grams to give a volume unit. So let's do that. Let's put 816 milligrams as the given, and then set up a conversion factor with milligrams on bottom so it cancels, and grams on top so we get the desired answer. And then to put in the correct numbers. So 1 milligram is 10 to the negative third grams. So we're going to take this times 10 to the negative third. Cool. The answer is 0.816 grams. That will be the mass in grams. Now, once we do that, we need to think, what can we do to get gram cancel gram? I want to have volume as an answer, which means this needs to be on top. So I'm going to take the grams per cubic centimeter, which is this, and I'm going to flip it upside down. That would give cubic centimeter volume as the answer. That's great. And what I can do next is multiply it by grams, and now gram cancels gram and just gives cubic centimeter for an answer. That's what I'm trying to do. Let's plug numbers in to make this actually happen. Now this is this unit, and since this number is attached to grams, if I flip it upside down, then 2.87 needs to also go to the bottom because it needs to stay next to grams. What goes next to cubic centimeters? An automatic number 1. Times grams. Okay, the number attached to that is this 0.816. 0.816 grams. Gram cancels gram to give your answer. Your calculator, well, I should show how to actually do this on a calculator. 1 divided by 2.87 equals, times 0.816 equals 0.284. 284,320,557 cubic centimeters. Infinite sig figs, don't worry about the 1. 3 sig figs, 3 sig figs, 3 sig figs, 0.284 cubic centimeters. That's the volume of this cube. All right, now let's look at the next one. All right, if we're going to attack this one, we need to understand a density is going to involve dividing grams by the volume. So we're going to take this turn to grams, use this to find the volume, and we'll just take the number of grams divided by the number of cubic centimeters. Cool, so let's, I guess let's do grams. Okay, 8.56 kilograms. We need to turn into grams in order to be able to get this. So I need to convert to grams. So kilogram goes on bottom so that they cancel, gram on top so that it provides the answer we want. And then 1 goes next to the derived unit, power of 10 next to the base unit. 10 to the third is the same as just writing 1,000. So it doesn't really matter, but I'll do it just to make it easier. And this times 1,000 is 8,560 grams. Now let's do this one. Let's get the cubic centimeters. 4.0 centimeters times 7.0 centimeters times 10.0 centimeters. And centimeter times centimeter times centimeter equals cubic centimeters. And if you do the math, this comes out to 280. The calculator will spit this out. 2 sig figs, 2 sig figs, 3 sig figs. Yep, you should have 2. 3 sig figs, infinite sig figs. Yep, this is 3. So these have the correct sig figs to reflect their origins. Cool. Now I just take the number of grams divided by the number of cubic centimeters in order to get the answer. So 8,560, oh, that's a 5, grams divided by 280 cubic centimeters equals, and then when you do the math, 8,560 divided by 280 is 30.57142.857 grams per cubic centimeter. Let's round that properly. Rounded properly, what you're going to get is, let's see, the calculated numbers, the smallest ones involve 2 sig figs and a d. That's a 2 sig fig number, and that's a 2 sig fig number. So 2 sig figs it is. 31 grams per cubic centimeter. And that's how you take care of that.